Good morning, students. This is next chapter in chemistry, that is solutions. Here the definition for solutions is the homogeneous mixture of two or more substances is called solution. Homogeneous mixture means uniform mixture. For example, if salt is present in water or sugar is present in water, then we get a uniform mixture. That mixture is called homogeneous mixture. The components present in the solution are called solute and solvent. The substances which are present in solution are called solute and solvent. The substance which is present in lesser quantity in a solution, that is called solute. Or one more definition is there: the substance which is present in dissolved form in a solution is also called solute. That is the another definition for solute. Lesser part of the solution, that is simple definition. One more definition is what? The substance which is in dissolved state. Suppose if you take example of salt in water. In that example, salt is in dissolved state, so that salt is considered as solute and water is considered as solvent. Next, the substance which is present in major quantity is called solvent in a solution. Or the substance in which other substance is dissolved is called solvent. That is also another definition for solvent. Example, if 10 grams of glucose is present in 100 grams of water, then solution is formed. We know that 10 grams glucose is considered as solute because it is lesser amount. That 100 grams of water is considered as solvent because it is major amount. Next, binary solution. Binary solution means if the solution contains two substances, that is called binary solution. If it contains three substances, that is called trinary solution. If it contains more than three, or we can say more than two, that is poly solution. But in our syllabus, most of the solutions are binary solutions, so we used to discuss about binary solutions only. Next, based on physical state of solvent, not solute, based on physical state of solvent, solutions are classified into three types. They are solid solutions, liquid solutions, gaseous solutions. That means in solid solutions, solid is the solvent, liquid solutions, liquid is the solvent, and gaseous solutions, gaseous is the solvent. Again, each solution is further classified into three types. They are this one. See, these are solid solutions. First one is solid in solid. That means for that example is alloys. Alloys means what? Mixed metals. For example, steel, bronze, brass. All these contains two or more metals. In that one metal is in lesser amount and other metal is in more amount. And they form homogeneous mixture. That is why they are called solutions. Which solutions? Solid in solid type of solutions. So all alloys are solutions, solid in solid type of solutions. Next, liquid in solid, not solid in liquid, liquid in solid. That means solid amount is more, liquid amount is less. For example, mercury is dissolved in sodium metal. Mercury is we know that mercury is present in liquid state. So when that mercury is dissolved in sodium metal, then we get sodium amalgam. When mercury is dissolved in zinc metal, then we get zinc amalgam. So amalgams means what? Metals with mercury is called amalgams. So these amalgams are also called solutions. These comes under liquid in solid type, not solid in liquid type. Next, gas in solid. This is the last type in solid solutions. Gas in solid. That means gas amount is less, solid amount is more. Example, exhaustion of hydrogen gas when it passed through palladium metal or platinum metal. Then what happened? That hydrogen gas is absorbed on the surface of the metal. That process is called occlusion. Occlusion means, this is the important definition for one mark. What is occlusion? Adsorption of hydrogen gas by palladium metal or platinum metal. That is called occlusion. in that process solution is formed. What is the solute? Hydrogen gas. What is solvent? Metal. Which metal? Palladium metal. Next, come to liquid solutions. Liquid solutions. In liquid solutions, first one is solid in liquid. So solid amount is less, liquid amount is more. Example, salt in water. Liquid, both are liquids, alcohols in water. Gas in liquid, that means gas amount is less, liquid amount is more. For example, soda water or cool drinks, all these comes under this category. Which category? Gas in liquid, because in that case gas amount is less and liquid amount is more. Next, gaseous solutions, that means in that one solvents are gas. First one, solid in gas. Solid amount is less, gas amount is more. What is the example? Camphor in air. Camphor. Next, liquid in gas. Liquid amount is less, gas amount is more. Chloroform in air. Chloroform is present in liquid state. Here camphor is present in solid state. Gas in gas. Best example, air. Air is the solution in which solvent is what, students? In which solvent is nitrogen, because it is in more amount. Next, if the solvent is gas, then they are called aerosols. If the solvent is water, then they are called aqueous solutions. If the solvent is alcohol, then they are called alcoholic solutions. So this is about introduction of solutions chapter. Next, methods of concentrations of solutions. Methods of concentrations. There are some methods to describe concentrations of the solutions. First one is weight percentage or mass percentage. It already came in 9th class. What is weight percentage? If the amount of solute is present in 100 grams of total solution. 100 grams of total solution is called weight percentage. If the amount of solute is present in 100 grams of the total solute. For example, if you see the example, then you will get clear idea. For example, 10% small w by capital W. This is small w, this is capital W of glucose in water. That means what? 10% small w by capital W glucose in water means what? 10 grams of glucose present in 90 grams of water, or 10 grams of glucose is present in 100 grams of the solution. Percentage means you should calculate for 100. So there are two ways. First one is what? 10 grams of glucose in 100 grams of solution, or 10 grams of glucose present in 90 grams of water. 10 plus 90, how much? 100. This W by W, capital W indicates what? Mass percentage. That is also called weight percentage. Here one formula is there. What is that? Mass percentage of solute is equal to mass of solute by mass of solution, means mass of solute plus solvent into 100. Similarly, mass percentage of solvent equal to mass of solvent by mass of solution, nothing but mass of solute plus mass of solvent into 100. Based on this, some numericals are there. We will discuss those numericals later. This is about weight percentage or mass percentage. Next one, volume percentage. Volume percentage, it is represented by small v by capital V percentage. Here the definition is what? The volume of solute present in 100 ml of the solution. The volume of the solute present in, like that, there in weight percentage. Now there, what is the definition? The weight of solute present in 100 grams of total solution. Here the volume of solute present in 100 ml of the total solution is called volume of the solution. If you see the example, then you will get a clear idea as in previous case. See, 20% V, small v by capital V, alcohol in water means what? 20 ml of alcohol present in 100 ml of solution, or 20 ml of alcohol is present in 80 ml of water. 20 plus 80, how much? 100. Then if you mix this alcohol and water, that is called solution. Here first statement is telling about solution, second statement is telling about solvent. That is the only difference. Next, weight to volume percentage, it is represented by W by V percentage. In first case, W by W, that means clearly small w by capital W. In second case, small v by capital V, but here small w by V. Here the definition is the weight of solute is present in 100 ml of the total solution. The weight of solute is present in 100 ml of total solution. For example, 10% W by V. glucose in water means what? 10 grams of glucose is present in 100 ml of solution. 100 ml of solution. We should not say that 10 ml of glucose is present in 90 ml of water. We should not say like that. See, sorry students, here 10 grams of glucose is present in, because here solute amount is present in weights and solvent amount is present in milliliters. So we cannot add amount of solute and solvent, because solute amount is present in grams, solvent amount is present in milliliters. So 10% W by V glucose in water means what? 10 grams of glucose. 10 grams. We should not say 10 ml. 10 grams of glucose is present in 100 ml of solution. That's it. 100 ml of solution. That's it. Next, that is the about weight volume percentage. Next one, parts per million. This is also one of the concentration method. Parts per million. Million means what? 10 lakhs. 10 lakhs is called million. So here the definition is what? Parts per million. That means in name itself some definition is there. The number of parts of which one? Solute. The number of parts of solute is present in 1 million parts. That's it. 1 million parts. The number of parts of solute is present in 1 million parts is called parts per million. Next one, molarity. What is molarity? The number of moles of solute is present in 1 liter of solution is called molarity. The number of moles of solute is present in 1 liter solution is called what, students? Molarity. Based on definition, we can write the formula, that is M equal to number of moles of solute by volume of solution in liters. Number of moles of solute can be represented by small n. Volume of solution can be represented by V. Number of moles formula what? Weight by gram molecular weight into 1 by V in liters. This is the formula in liters. It can be converted into milliliters. Then we get this formula, that is what? Molarity equal to weight by gram molecular weight into 1000 by V in ml. We should remember these three formulas, because sometimes they give you question in number of moles, or sometimes they give you question in liters or in milliliters. So we have to remember these three formulas. All these formulas are obtained from this definition. Next, there are some more formulas. For molarity. Before that, I will discuss one point. What are the units? Based on definition, we can say the units. What are the units? Moles per liter. This is the dimensions of molarity. Next, there are some more points regarding molarity. They are, if molarity value is 1, that is called molar solution. If molarity value is 0.5, then that is semi-molar. If it is 0.1, that is decimolar. If it is 0.01, that is centimolar. If it is 10, that is decamolar. 1 means molar, 0.5 means semimolar, 0.1 means decimolar, 0.01 means centimolar, 10 means decamolar. Next, there are some more points regarding molarity. They are M equal to 10 into weight percentage by gram molecular weight of solute. That means when weight percentage is given and molarity is to be found, then we should use this formula. When weight percentage or mass percentage is given in numerical, in that numerical, if molarity is to be found, then we should use this formula. What is the formula? M equal to 10 into weight percentage by gram molecular weight of solute. Sometimes along with weight percentage, they give density or specific gravity. What is specific gravity? Density or specific gravity is what? Density of given substance by density of hydrogen. Density of given substance by density of hydrogen. That is called specific gravity. Of course, no need to remember about the definition. You just remember. Sometimes what along with weight percentage, density or specific gravity will be given in question. Then molarity is to be found. Then we should use this formula. What is the formula? Same formula. We should add that density factor or specific factor in numerator, then we can find molarity value. So this is about molarity.